Welcome to Study Loop.
Okay, so this is a projectile problem, and it would be easier if it didn't stipulate the whole thing about the can. So always helps to draw stuff out. So here's the tabletop, and then there's a can over here, and that's what they're trying to hit, right? So it tells you that this height is 1 meter, and the can is zero point 0.2 meters tall, right? So that means that in order for this thing to make it, it has to clear the lip of the can, right? So it may land a little bit further, but it has to clear the lip of that can. So if I put that can right here, it wouldn't make it, right? So that's important. Okay, so there's two parts to this, and it's also going, whoops, it's also going 8 meters per second. Okay, so we've got to think about this in the horizontal direction and the vertical direction because it's behaving differently. The first thing we got to do is figure out time. Time is the thing that connects the two dimensions. So I know how far this thing is going to fall, right? And I know that since I need to clear the lip of that can, that I'm going to make the distance from the tabletop to the lip of the can, I'm going to make that my height. So that's going to be my delta y. And so if it's 1 and that's 0.2, this is 1 minus 0.2. So the height is 80 centimeters or 0.8 meters. Okay, so for something in free fall, right, because this thing takes off going horizontal, there's no initial y velocity. The formula to get the time, all right, so time is 2 times the height divided by g square root of that. So if I do this, that's 2 times 0.8 divided by 9.8 square root of that. And that comes out to 0.404 seconds. Okay, so that's the time this thing's going to take to hit the ground. So now I can use my velocity and I can solve for the distance, right? Because in the x dimension, the only equation that applies is velocity is displacement over time, right? There's no acceleration in this dimension. So I'm going to take my time. I know velocity is delta x over delta t, and I've got the velocity here, and I'm going to plug in my time here, and I can solve for delta x. So delta x is velocity times time. That's 8 times 0.404. And if you do that, you get 3.23 meters. And that's exactly what it says. It says show that they score a bullseye when they place it 3.2 meters. So if they place it 3.2 meters and 3.23 meters is right here, then they're going to clear the lip of that can, which was right here, and they're going to make a bullseye.